So the folks at LiTime reached out sometime last June, I think, and they were offering a product for me to test and review on our channel. But of course, summer is travel season for us, so this is the kind of work that has to wait for winter. So they agreed to wait, and look what showed up last week. So at the time, my thoughts were a power solution for Jeans JK. And of course, well, in the meantime, some new project ideas showed up. And a couple of months ago, the folks at Lensun Solar reached out as well, and they said, we've got some ideas for you as well. So somewhere along the way, I lost track of what I was doing actually, and I think I've screwed up here. I've kind of put the cart before the horse. So I got to go back to the drawing board, figure out what my options are, and see what we can do here. Typically, what I like to do is figure out what your power needs are and then develop the system based on that. Well, I got it backwards. So I remember years ago camping with friends with our holiday trailer, and I had a solar panel and dual battery setup, 12-volt setup. And we would go for a long weekend or a week and never run out of power. It suited our needs perfectly. And I remember going with friends and they would complain that by morning the battery was dead, or by the end of the weekend they ran out of power. And the solution is very simple. You need to have more power capacity than what you consume or what you use. So my approach is figure out what my needs are, and then we can build a system to meet those needs. And as a rule of thumb, I like to double that. Never run out of power. So with the Overlanding setup, quite simply what we have going that consumes power, 12-volt power, is number one, our fridge, and that demand is greater in the summer than in the winter. And of course in the winter we have our diesel heater, and it doesn't have a demand in the summer. So those two kind of complement each other for power needs. And of course, while filming for YouTube, our camera batteries consume a lot of power to keep those charged up. And that in itself is quite a chore actually. And for the future, I want to improve our camp lighting situation. We are using rechargeable batteries for the most part, or drawing off the vehicle battery, and it's working fine, don't get me wrong, but I'd like to improve that in the future. So what do we have? Well, we've been running everything off the vehicle battery, which is okay. We've not had any issues. I'm very aware of our power consumption, and that's okay. And in the summer, it's not a problem if you run down the battery. It's not a big deal. Our fridge protects the battery. It will shut down, and I think that's only happened once on a 3-day August long weekend that it was super hot. We rarely stay put for more than one night, 2 days max. But one August long weekend, last year, year before, we met up with Rebellion Off-Road and we spent a long weekend with them, which was quite nice, but it was super hot. The fridge was running just about constantly and it went into battery protection mode. And I think it was in the morning, the fridge temperature was climbing because it had shut down. No big deal, ran the vehicle for a few minutes, charged up the battery back up, and we're great for the rest of the weekend. But I'd like to be able to avoid that. Who knows, we might run into a situation where we will stay put for a week or so. Our plans are so fluid, we never know what we're doing. So what do we have? From LiTime, we have a 100 amp lithium battery. We have a DC to DC charger, a 40 amp charger that is suited to that battery. And we also have a new solar panel. About a month ago, the folks at Lensun Solar Panels provided this well-packaged hood-mounted solar panel. So we'll have to unpack this one. It is paper thin. This will be a really cool addition. And of course it comes with all the mounting hardware and a charge controller as well. So here's the thing. I initially intended to just run a house battery for Jean's Jeep to run the fridge so we could leave that starting battery alone. And then new project came in, and by the way, we'll release that shortly here. We're going to keep it under wraps for now. And then the solar panel showed up. All right, so what do we do? Well, I thought, you know what? We put all of this in Jean's Jeep and it can supply the fridge and the heater and the battery. So I'm thinking with a new project, maybe we should split up the electrical load between the two vehicles. So here's my options. We could set up the solar panel with the lithium battery for Jean's JK to supply absolutely everything. We could set up the solar panel just on the starter battery to make sure it's always fresh, and maybe you run the camp lighting off of that. That's a small need. And separate the two systems. We could put one system, the solar panel, on my new build, and we could maybe leave the lithium battery for the fridge, or a combination of any of that. We have some options here. So what we need to do is we need to figure out what my power needs are for each vehicle and what solution might fit best. And the only way to know that is to do a little bit of calculating here. I need to know what the power needs are for each item and the power solutions that each of these components provide. So it's time to do some measuring and some calculating. So I quickly looked up the current draw on the fridge, and well, you know what? They give you kind of a maximum rating. So you know what? We're going to test that one as well. I just got to wait for Gene to come back with a power cord. But what I will do is test the diesel heater. So what we're going to do is we're going to hook it up to a 12-volt battery, just like we would normally run it out when we're using it. We're going to measure the current draw while it's heating up, and then get a baseline from when it's just running during the night. I'm just going to measure the current flow with my DVOM and an amp clamp. That way I can measure the current by inductive means. All right, let's turn it on. So the glow plugs have turned on. I saw 9 amps. We're at 9.2 amps right now. And I hear the fuel pump clicking away. We are currently at 8.7 amps. We'll let it do its warm-up cycle, and then we'll see what the current draw when it's running, because that'd be the bulk of the power draw for this heater. So diesel heater's been running for about 10 minutes or so, and I had my meter to set to record minimum and maximums, and as well as an average. So in that 10 minutes, the current draw was 1.6 amps. So now we got a baseline for it. Anything that is this well packaged must be on the delicate side, so we're going to be careful with this. Now you can get a panel for a TJ, but this one's for a JK, so it doesn't fit very well, but I'm just going to leave it on the hood. We have some clear skies and a pretty low sun for this time of year. So I got a flashing green light and a yellow light. The flashing green tells me the solar panel is charging. The yellow says the battery is normal, and the red being off is working properly. So let's go see what we're charging on the inside. So of course it's mid-November and the sun is pretty low in the sky. This is probably the worst case scenario for that solar panel, and I've had it on charging this battery for I don't know, about 20 minutes now, and it's charging a consistent 1 amp. So that is kind of on our minimum for what we're doing. All right, I'm super impressed with how well this solar panel, this hood-mounted solar panel, has performed in really the worst conditions that we can have it operate in. And I even put it in the shade, and I was still getting 1 amp. So I like this. This will keep that lithium battery topped up when we need it. So I think what we charge most often is GoPro batteries, this type of battery, or our cell phones. So that'll make a pretty good test, and we usually charge about a half dozen at a time typically. So I have 6 batteries here that need to be charged. I'm going to zero my meter with this USB adapter here from DeWalt, and I'll plug it in and see what we draw. And that should give me a pretty good baseline. I'll try my phone as well. And I'll plug one in. And that's 0.2 of an amp. And we'll plug a second one in. They're both charging. Yeah, I'm gonna say about 1 amp. So let's see my phone. It is at 80% charged, and as it's charging, well, that's less than half an amp. It's 0.4 of an amp. So what did I say for the batteries? Did I say 1.5 amps? 1 amp. So I think it's safe to say that charging some devices, some batteries, typically will be under 2 amps, maybe 1 amp. So let's call it 1.5 amps. I think 1.5 amps would be about what we would need on a regular basis. Okay, so now we'll turn on the fridge and check it. Let's see what it draws. So it's ranging between 3.2 and 3.8 amps, somewhere around there. And of course it's working pretty hard right now because it's cooling it down. So we're gonna call that 3.5 amps. Okay, so in terms of camp lighting, I'm looking at some lights, some light strips I'm interested in building. My best guess is 2 amps with a winter camp type setup with all the lighting on based on those light strips. So we'll add 2 amps for that. So what are we talking about? Well, there's a little bit of terminology there, right? And if you know all this stuff, bear with me a little bit, but if you're a little unsure about what voltage and amperage and watts and all that and what that's all about, not all of us are really comfortable with this terminology. So we say it's a 2.8 volts at 100 amp hours. Well, what the heck does that mean exactly? Well, here's some basics. So electricity basically is electron flow or energy flow in a conductor. And think of it this way. Voltage is that electrical push. How much pressure is pushing electricity down the conductor? Amperage is current, the amount of energy flowing, the amount of electricity flowing down your conductor. Watts, on the other hand, is a measure of energy, if you will, and it's super easy to calculate. It's basically how much current with how much push. So voltage times current gives you watts. So if you have a 12 volt battery with 1 amp current, you got 12 watts of energy, if you will, of power. If you have a 12 volt battery with 10 amps, well, that's 120 watts. So in this case, this battery is 100 amp hours or a energy capacity of 1280 watts per hour. Watts are especially useful when you're working with a residential setting, if you will, because you got different voltages, right? So your big power, your dryer, your oven, that kind of stuff is on 220 and or 240. And when you're talking about your lighting, everything else in your house is running on basically 120 volts. And then all your electronics, well, they're basically a 12 volt system. So your phone charger is what, 7 volts, something like that. So to calculate wattage is quite useful there. But in the automotive application, well, your voltage is constant. It's all a 12 volt system. Now, granted, it changes, right? So when the alternator is charging, you're closer to 14 volts, but basically we're talking a 12 volt system. So personally, watt hours, not something I work with. It's super easy to work with amp hours. So quite simply, if the heater, for example, draws 1.6 amp, and it's on for a whole hour, well, that's 1.6 amp hours. It makes the calculations, the math really easy. So what does that mean? Well, looking at our fridge and our heater requirements, it looks like our power needs are quite different from winter to summer. So in the summer, basically we got the fridge, no diesel heater, camera batteries doesn't really change, probably less because they're not cold. And our camp lighting, well, we don't really need that for the most part. It's dark around here, 11 o'clock at night, so we're in bed by then. So the fridge runs about a third of the time, like a 30% duty cycle. So let's say that it's on for 8 hours of the day, because of course it doesn't run at night when it cools down. Power needs change all the time, but that's about what we've seen that seems to be. So that math makes sense. So that would be 28 amps per day. And we add our battery charge time. We charge our batteries about 4 hours a day. So let's say 6 amps. That brings us to a total of 34 amps each day. So if we have a 100 amp hour battery divided by their 34 amps per day, that's basically 2.9 days, 3 days. And that's pretty much what we're seeing. The only time our fridge stopped working for lack of power, it was on the 3rd day. So that makes sense. Now for our winter needs, the fridge doesn't run. It's just turned on, so it draws next to nothing. But our diesel heater, because it's dark so early and daylight so late, we're basically running at about 12 hours a day. So 1.6 amps for the 12 hours, that's a 19.2 amps per day. Our camera batteries doesn't really change my calculation here. We'll leave it at 6 amps. And our camp lighting, well, at 2 amps, let's say we're on for 2 hours. Let's say 4 hours a day, that is 8 amps for a total of 33.2 amps. So again, our 100 amp hour battery divided by 33.2 amps, we're good for 3 days even. So 2.9 days in the summer and 3 days in the winter. That's exactly what we need. All right, so I know what I got going on here. It looks like a bit of a science experiment, but basically all I have is my high capacity lead acid DC 12 volt battery, a DC to DC charger that I have set now at 20 amps, and the lithium battery is now powered up. So once the battery is connected and powered up, it's turned on, I can now communicate with the app. directly with the battery, and it is currently at 53% charge. So I'm going to let that charge up so it's ready to use later. So all kinds of useful information on the app. It is currently 54%. It's currently charging 3.5 volts. Charging at a current of 20.4 amps, which is what I want to limit the charging at. I want it to charge a little bit lower charge. 375 watts of power going in, and it currently has a 54 amp hour capacity. So basically, we'd be good for a day and a half, just the way it is. Battery temperature at 16 degrees. It's never been cycled, no cycle time. And so on and so forth. So all kinds of useful information as we manage our power demands while we're on the road. Love that. Now, the battery has a self-heating function for charging in the wintertime. So we all know that lithium batteries, when it gets cold, they won't take a charge. So when charging at cold temperatures, it will automatically turn on to warm up the battery. Let's have a look at this here. So the heater will turn on anytime that we're charging the battery when the battery is between +5 Celsius and -20 Celsius. So since we do use our setup in winter quite a bit, that'll be handy. Now keep in mind it's using internal power for that heating, right? That's going to reduce its energy capacity. So specs are written right on top of the battery. So we have a 12.8 volt battery, 100 amp hour capacity, a rated energy of 1280 watts or watts hour. Charging voltage is 14.4 volts, give or take 0.2 of a volt. And we are currently at 13.5. And that's basically the same as our Jackery that we're using currently. So that will become exactly what we've been needing, but now permanently installed in-house. I think that's the plan so far. So the solar panel is pretty straightforward to install. It is custom sized for your vehicle. So in this case, this is for a JK. Wouldn't fit on anything else, but you can get the correct panel for whatever vehicle you have. I'm not ready to install it, but it is affixed to the hood by using two-sided tape. And all the way around the perimeter, strips in the middle, you locate it and stick it to the hood. And then it's quite simply just a matter of running and hooking up the electrical, connecting the panel to the charge controller to the battery, and there is load connections as well. Mounted somewhere secure. I would mount it protected from the weather as much as possible, somewhere where it can get a lot of cooling, and we're good to go. Now, I'm probably going to mount the solar panel directly to the hood on my new build, but if you're not too comfortable by potentially damaging your paint, no big deal. So they provide a sticker that you can apply directly to the hood. Solar panel goes over top of it, and then you're not going to damage your paint. Now, I don't know if you've noticed, if you've been watching the channel, we don't care too much about pinstriping or damaged paint. It's part of what we do, unfortunately. Now, I've been a big fan of the blacked out hood. They say it's to not reflect so much light from the overhead lighting of the light bar. I don't know how much difference that makes, but I just like the look of it. And I've always wondered how to best black out the hood on Gene's Jeep, for example. It does it for you, so I like that. Simple install, the panel is out of the way, seamless integration into the vehicle. Just plug it in, forget about it. Love this system. The solar panel is super easy to monitor. It's done with a phone app. Currently, I got the panel just in the shop here with the shop lighting. It's plugged in. I got it hooked up to my test battery. So currently, the battery is at 12.48 volts, so it needs a little bit of a charge. And it's receiving a 0.05 amp charge currently. The panel that is just plugged in the shop with the shop lighting here is charging currently at 72 watts. So very handy to be able to monitor what's going on as you're setting up camp, trying to judge what you're going to have for power. That's pretty handy. So to recap, what we have is we have a 100 amp hour battery with a 40 amp DC to DC charger that will satisfy our power needs, no problems. And we're going to supplement that with a solar panel. I think we have what we need here. We should be able to basically be on the road indefinitely. We are good for 3 days sitting, which we rarely do. We're usually moving every day, so we'll continuously keep charging our battery, and the solar panel will extend that. depending on weather conditions, of course. So here we are. I now know what I have and what I can do with it. My thoughts were that battery will run the fridge and the heater from Gene's Jeep. Permanently installed, we don't have to carry anything with us. I like that setup. Solar panel on the hood that will supplement our power need. Cooling fan just turned on the charger. Oh, that didn't run long at all. But here's the problem. Gene has a custom sticker on her hood, and I was talking to her and she doesn't really want to give that up. So in hindsight, I actually have a set of solar panels I was using for our RV. Those would go on the rooftop tent because there's some tracking on the top. I could fabricate a mount. We could put even more capacity up there. I kind of like that. Perhaps solar panel goes on my Jeep. So another option, lithium battery, solar panel on the rooftop tent, runs the fridge and the furnace and whatever camp lighting we can use in Gene's Jeep. And on my Jeep, we use the hood mounted solar panel with perhaps our Jackery, a portable power source. And it would power up all our battery charging needs. Less power demand, smaller system with a Jackery or another power generator. I like that. I think that's the direction we're taking. With what we have on hand, we have our DC to DC charger, so anytime we're driving, we're going to be charging that battery and adding to it. And of course the solar panel, as long as we got some kind of sunlight, it's adding a trickle charge to our battery. So we're going to say that either case scenario, it is 3 days plus. And that's exactly what we need.